Well, hello. My name is David, as you may well know. And during the filming of this next video, I made one mistake. And I caught that mistake and corrected it during the course of the video. And I decided not to edit it out to provide two pedagogic benefits. Number one, you will see that even experts, such as myself, will make errors. And so, you don't have to believe the mythology that the math teacher always gets it right, because that's not true. We all make mistakes, and but we just try and work on doing things correctly so that we can improve. And the second pedagogic benefit is that I'm going to challenge you as you're watching this to follow along with the calculations to see when I make my mistake, and you'll see immediately afterwards when I correct it how to do it properly. And so I'll let that be a challenge to you. And enjoy. Hello, my name is David again, and today what I'm going to be talking about is how to calculate with fractions. All too often, my customers come to me looking for a way to solve them with one problem or another, and I find that they're deficient in their knowledge of how to calculate with fractions. And I think that calculating with fractions is a very useful skill, and also, it is helpful on the SAT and the ACT. It is helpful, when you're just doing a problem just generally, and it just makes you feel more confident. And without further ado, I guess here we go. So basically, we're going to talk about today's fractions. And the first thing that you need to know is what a fraction looks like. And so, for instance, let's take this fraction, for example. This fraction is commonly known as 2/3. And it has a numerator, which is the number at the top, a numerator, and it has a denominator at the bottom, denominator, and this fraction, if you go back to high school, if you go back to elementary school, the way they would describe this fraction is that if you take a pizza and you slice it into 3 pieces like this, evenly. Right, this is my pizza. Then 2/3 of the pizza will be 2 out of the 3 slices. So that's the way that we want to think about fractions. We want to think of them as, this is how many parts the whole has been cut into. So this is the idea. The denominator is the number, how many parts the whole has been cut into, right? Right. So in this case, we can see that in the pizza example, it's been cut into 3 pieces. And the numerator is the number of pieces the fraction represents. So in this case, 2. We see that 2 of those pieces out of the 3 that the pizza has been evenly sliced into are represented by the fraction 2/3. And so that's the idea of a fraction. A fraction is a part of a whole. And it's a great way to summarize information about how much of that whole has been, is represented. And So now, while we're on that topic, I want you to see something very special. If you have, one of the facts that we're going to need to know is that a fraction with the same numerator and denominator is equal to 1. And this makes sense because if you take a pizza, let's say you take 1 pizza, right? And we slice it into 3 pieces, like this. I sliced it into 3 equal pieces. They may not be equal in this diagram, but we're assuming them to be equal for the purposes of our discussion. And if you take the three pieces together, right, that's the whole pizza. So whenever you have a fraction that has the same numerator and the same denominator, it's always equal to 1. And this is absolutely crucial to one of our discussions later on in this video. So that's one of our major facts. A fraction with the same numerator and the same denominator is always equal to 1. Now, let's see. Now, let me give you another example of a few more ways of looking at this. Like 1/2, we can take our pizza, okay, and we can slice it into 2 equal pieces because that's the denominator is the number of pieces that the whole has been sliced into, and it says here that this is 1/2 of the pizza. So only one of those 2 pieces is to be shaded, like this. So this is our pizza piece that is represented by this fraction. 1 out of the 2 equal pieces it's been sliced into in this area. Beautiful. Now the first operation with fractions that we're going to talk about is multiplication. And I know you might be thinking, well, shouldn't we do addition first? Or shouldn't we do subtraction first? But I assure you that by doing multiplication first and division first, we're going to cover a lot. We're going to cover the whole arithmetic of fractions much more seamlessly. So multiplication of fractions, okay. So multiplication of fractions is the easiest thing in the world. Check this out. I'm going to do an example first, and then I'm going to explain in words what I'm doing. I have the fraction 1/2, and I'm going to multiply it by 2/3, okay? To get the product, the numerator of the product, which is the number on top, will be the product of the numerators of the 2 fractions we multiplied. In other words, 1 times 2 is 2, and the denominator of the product will be the product of these 2 of the denominators of the fractions being multiplied. I want you to try. I know that might be a lot as a big sentence to understand, but if you repeat it to yourself a couple of times, and I'm going to write it down in a moment, you're going to see that it's absolutely describing what I'm doing. So 2 times 3 equals 6. So this then is the product of these 2 fractions. Again, let me show you another example. So 2/3 times 1/5. That's a bad looking 5. I think I gave that one a haircut. Okay, this one's much better. Right? Notice here I'm using a little dot to represent multiplication. This is also, used. People use this and people use this. It's the same thing. 2 times 1 equals 2. And 3 times 5 equals 15, right? And so that's the product of these 2 fractions. Now, here's the thing. I'm going to state that as a rule. Oh, yeah. I'm going to state that as a rule now. The product of 2 fractions has a numerator which is a product of the numerators of the 2 fractions being multiplied. which is the product of the two denominators of the fractions being multiplied. Okay. Like this. This is like the exact describing. We can do another one. 2/5 times 3/9 equals the numerators, right? So 2 times 3 equals 6, and 5 times 9 equals 40. Okay. Now this fraction can be simplified, but we'll talk about simplifying it a little bit. So right now we're going to leave it like this. But this is still like the correct product. And same thing over here. Let's do 1/3 times like 4/2. Okay. So it'll be 1 times 4, which is 4. And 3 times 2, which is 6. Okay. So this is how you multiply fractions. I mean, it's just that simple, believe it or not. What I want you to do as you're watching this video is I want you to work along with me and like try and make up your own examples to play with, so that you can make sure you convince yourself of that you understand what we're doing. Yes? Perfect. Because that way you can get the best educative effect. Now, there's another thing I want to point out here. There's two things I need to point out here first, now that we're about to talk about division of fractions. The first thing I want to point out is that any number, any whole number, let's say 3, is equal to 3/1. This actually is true not just for like numbers like this, but like for instance, 1/2 is also equal to 1/2 divided by 1. You know, square root of 2 is equal to square root of 2/1. Okay. So anything, so now I wanted to bring this example in because it's going to help us right now when we add fractions. But these two examples also show that it's not restricted to numbers that are not fractional or that are even irrational, like the square root of 2. But anyway, let's get back on track. So that's one little thing. And now the other thing we're going to talk about is what is a reciprocal? A reciprocal. Let's say we have a fraction 1/3. The reciprocal of 1/3 is going to be 3/1. I want you to notice what I did. I flipped it over like this. The denominator of the original fraction becomes the numerator of the reciprocal, and the numerator of the original fraction becomes the denominator of the reciprocal fraction. And I can give you another example. So let's say I take 2/3 and I want to find its reciprocal. The denominator of the original fraction becomes the numerator of my reciprocal, and the numerator becomes the denominator. So you just basically flip the fraction to get the reciprocal. And so that when you think of reciprocal, that's all you have to know. That you just flip the fraction over like this. And now we're going to apply that. So we're going to divide fractions. Now, the division of fractions is just as easy as the multiplication of fractions. And you're going to see why right now. So I'm going to start off with an example. I'm going to take this fraction, let's say 1/2, and I'm going to divide it by 2/3. Okay? Watch what I'm about to do, because this is just critical. This is going to equal this fraction is going to stay the same, the 1/2. This division sign is going to be a multiplication sign now. I'm going to change it to multiplication, and I'm going to take the reciprocal of this fraction, 3/2. And then I just take this product, and it's going to be, and that's the answer. So in other words, 1 times 3 is 3, and 2 times 2 is 4. So now we can say that 1/2 divided by 2/3 is 3/4. In other words, when you're dividing one fraction by another, you take the original fraction and you multiply it by the reciprocal of the fraction you're dividing it by. Let's give another example here. 2/3 divided by 1/6. Right? So this is going to equal this. Look, watch. I'm going to take this one. Okay. 2/3 is going to stay the same. The first fraction stays the same. This turns into a multiplication sign. And this, we get the reciprocal, which is going to be 6/1. And now we multiply these fractions. 2 times 6 is 12. 3 times 1 is 3. Now, I don't know if you know this or not, but 12, whenever you have a fraction like this, we can calculate what this is more or less. Like in a case like this, it's very easy to see or rather, let me continue and then we'll talk about simplifying fractions. Yes. But we'll just say that this one simplifies to 4 for now. And I'll show you why in a few minutes. Yeah. Or intuitively, I can show you right now. Let's talk about pizzas. I'm going to give you this example. I'll show you how to simplify later in a few moments. But let's say we have a pizza divided into 3 pieces, right? Well, I need 1, 2, 3. I don't have enough pizzas yet. So I'm going to take another pizza that's divided into 3. And I'm going to get 4, 5, 6. I'm not there yet. Take another pizza divided into 3, like this. They're divided into 3 because that's how many parts of the whole, has been divided into. 7, 8, 9. We're not there yet. Finally, with our 4th pizza, we get 10, 11, 12. So now we know that we need 4 pizzas to have 12 slices of pizza that are each 1/3 of the original pizza. I hope that kind of makes sense. And but if it doesn't, don't let that bother you. This calculation technique is absolutely foolproof because this is like and it's absolutely easy. Let's do another example. 2/3 divided by 5 eighths equals 2/3 times the reciprocal of the second fraction, 8/5. 2 times 8 is 16. 3 times 5 is 15. Right? Perfect. There we are. Division of fractions. And it's just as simple. So in other words, to divide one fraction by another, you take the first fraction, you change the division sign to a multiplication sign, and you multiply it with the reciprocal of the second fraction. And it's just that simple. If you had, now let me show you let me show you something here that's very special, because you might have a problem like this. 1/2 over 3/4. Now, this actually means, I want to say equal because it is equal, but it actually means, and this is going to be important right now, this actually means 1/2 divided by 3/4. I want you to pay attention here to this part right here, because this fraction bar doesn't just mean parts of the whole. but it also means like division. So in other words, in this case, 12 over 3, this is kind of like the idea of how we simplify fractions. So 12 over 3 means 12 divided by 3. And I'm sure all of you know that that's 4. And so that's how you would simplify in this case. 16 over 15 here, right, would mean 16 divided by 15, which, as you know, 15 goes into 16 once and has one remainder. So that remainder would be 1 over 16. I mean 1 over 15, right? That's 1 over 15. 1 and 1 over 15. Right. And so let's continue. So this is division of fractions. So in other words, like you could get, and then of course, so let me do this one as an example for you. So this would mean this, and we could calculate it using our technique now. We would have 1/2 divided by 3/4, which is equal to 1/2 times 4/3, which is the reciprocal of this fraction, equals 1 times 4 is 4, and then 2 times 3 is 6, and you know, that's your answer. We're going to teach how to simplify fractions in a moment, but for now, that's your answer, and it works. And so here we know that 1 over 2 divided by 3 over 4 is equal to 4 over 6, like that. So now we have done division of fractions. Okay. Now we're going to talk about something very special. This this is going to be a little bit different to a lot of the things that you might be used to, in the sense that, or not different from what you were used to, but this is something special, and that is, like, is there a way that two fractions can have the same numerical value but be different in the numbers that they have? And the answer is yes. And this is going to be important for the purposes of adding fractions, which is why I did multiplication first. You're going to see that right away. So like we said earlier, a fraction 3 divided by 3, or 4 divided by 4, or 5 over 5, they're all equal to what? 1. So check this out. I can multiply, if I multiply 3, or let me take a different number here. If I multiply 5 times 1, I get 5. Same number. If I multiply 1/3 times 5 over 15, 5 over 5, well, 5 over 5 is 1. This is 1. Okay? But this product is equal to 5 over 15. Okay? Because we multiply the numerators and we multiply the denominators. But look at this. What we know now is that 5 over 15 equals 1/3. It's the same. If I take a pizza and I slice it into 3 equal pieces, okay? This is gonna be my 1/3 piece. But watch this. I'm going to slice this pizza into 15 different pieces. Now, watch this. Right? That's 3 pieces. Then I'm going to slice this one into 5 pieces. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is 15 pieces, and I'm going to highlight 5 of them because it's 5 chosen over. So I'm going to highlight 1, 2, 5. So it's going to be all of this part. And of course, I'm doing this right on the board, and so like my drawing may not look perfect. But if you do it like perfectly, you will see that this piece has the same size as this piece. So these two fractions represent the same quantity, and this is important, and you're about to see why. So let's do another example. Two-thirds times 4/4 equals 2 times 4 is 8, 3 times 4 is 12. So 2/3 equals, so 8/12 and 2/3 represent the same fraction, but the only difference is they have a different denominator, and this is absolutely critical when we're adding fractions. Because, so now I think you get the idea. We're going to say that two fractions are equivalent if you can find a fraction that's equal to 1, which when you multiply it, you get one fraction from the other, or vice versa. Now you don't have to know that. I just wanted to say that because it gives you a good idea to think about. In this case, we could get 5/15 by multiplying 1/3 times 5/5. And you can get, and if you multiply 5/15 times the fraction 1/5, okay? If you multiply this fraction by this fraction, you get 1/30. So this is a fraction equal to 1. You multiply, you can get, in other words, from one fraction you can get the other by multiplying by a fraction that represents 1. This fraction is 1 because it has the same numerator and same denominator. This fraction is 1 because it has the same numerator, same denominator. Anyway, we're going to move forward from this, but I just want you guys to see this because we're about to use it. So check this out. We're going to add fractions now. The thing is that if you have two fractions with the same denominator, okay, it's very easy to add them. Let's say we're going to add 1/5 plus 2/5. Well, if they have the same denominator, watch what happens. We can do this. We can put them over the same denominator, which is 5. And we can say 1 plus 2/5, which is equal to 3/5. Okay. Let me do another example for you. Let's say we're going to add 1/4 plus 1/4. Well, we're the same denominator, so we just say 1 plus 1/4. And this is the same as 2/4. Okay. Like that. Okay. If we have the same denominator, we can add, 5/35 plus 6/35. No problem. Same denominator, so we can just take the denominator over 35, and we have 5 plus 6, like this. And then 5 plus 6 is 11, so our sum is 11/35. Now the reason why we talked about fractions which are equivalent is because of this problem. So remember, if you want to add two fractions with the same denominator, you add the numerator and you place them over the denominator that they have in common, right? So just again a recap: 1/3 plus let's say 1/3. They have the same denominator, so you add the numerators, which gives you 2, and you keep them over the common denominator, which is 3, like this. So 2/3. Now the question is, what if they don't have the common denominator? What if they don't have that same common denominator? Let's say I'm going to add 1/2 plus 1/5. Okay, we cannot do that with that technique. We need to find a common denominator for them. And what we're going to do, the most foolproof method of doing this is just to do the following. Check this out. I know that if I multiply 5 times 2, I get 10, right? Because I can take this number. right? 5 times 2 equals 10, and 2 times 5 equals 10 also, right? So watch what I'm going to do. I'm going to take my fraction 1/2, and I'm going to multiply it by 1, but in the form 5 over 5, right? And I'm going to add this fraction, which is 1/5, but I'm going to multiply it by 1 in the form of 2 over 2. Because I just used this number to make the second fraction, and I used this number to make the first fraction. Because I know that when I multiply these two, what I'm doing is I'm going to multiply these two numbers at the bottom, and they're going to give me 10 as the common denominator. And because I'm multiplying by 1 in both cases, this fraction that I'm about to write, 1 times 5 is 5, 2 times 5 is 10, plus 1 times 2 is 2, 5 times 2 is 10. These two fractions are equal to these fractions, but have the same denominator. And now I can add them. I place them over the same common denominator, and I add the numerator, like this. And now finally, we know that these two fractions add to 7 over 10. So 1/2 plus 1/5 is 7 over 10. How did we get a common denominator? We got a common denominator by multiplying the original fractions with a fraction, with a suitably chosen fraction. A fraction that is equal to 1, but which has a denominator that will multiply with the original fraction's denominator to make the common denominator you're looking for, in this case 10. So since we're looking for a common denominator that's 10, since we're looking for a common denominator that's 10, we would multiply 2 times 5 and 5 times 2. And there we go. Now, if you said, well, David, how would I know what would be a good common denominator? So let's do another problem. So how do I know what would be a good common denominator? Let's say we have 1 over 3 and 1 over 15. Okay. So here's how you do it. You're going to make a table of the multiples. You're going to start with 3 on the top and 15 on the bottom. Okay. And what you're going to do is you're going to take, like, let's say 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And 3 times 5 is 15. And here on the bottom, you're going to do multiples. So 15 times 2 is 30. Times 3 is 45. Times 4 is 60. And so on. And you're going to look for the number that they have in common. In this case, we already found it. 15. This is known as the least common multiple. So we know that 15 is going to be the fraction. This is going to be our denominator that we're going to use. We're going to use 15. So equals. Now, what times 3 gives you 15? 5. So watch what I'm going to do. I'm going to take this fraction 1/3, and I'm going to multiply it by 5 over 5. Because I want the denominator of the product to be 15, and the denominator of the product here will be 5 times 3, which is 15. And then I'm going to add the 115, and it's going to give me 1 times 5 is 5, 3 times 5 is 15, plus 1 over 15, which is equal to 6 over 15. Okay? And there you have it. And let's do a few more examples like this. I really want you guys to get a grip on exactly how I'm doing this, because I want you guys to play with some numbers at home, and I want you guys to get a sense that you can do this too, because you can. This is especially meant to anyone who has difficulty calculating with fractions. And again, in some cases I haven't simplified fractions, but that's because, when you're learning to walk, you can only learn so much before you can advance further. And I want to give you a good foundation. And later on, you'll be able to simplify fractions and do everything else, But this way, we're going to get you off on a good running basis. So let's say 1 over 7 and 1 over 3. Okay. Okay, so let's make our table again. We're going to start with 3 and 7. And what we're doing is we're calculating multiples. So this is 1, right? It's 2. So 3 times 2 is 6. 7 times 2 is 14. So 3 times 3 is 9. 7 times 3 is 21. Okay, we're going to continue this table. 3 times 4 is 12. 7 times 4 is 28. 5. 3 times 5 is 15. 7 times 5 is 35. 6 times 3 is 18. 6 times 7 is 42. And then 7 times 3 is 21. And 7 times 7 is 49. Aha! Look at this. 7 times 2 is 20. 7 times 3 is 21. And 3 times 7 is 21. Aha! So we're going to take our original problem, 1/7 plus 1/3. We're going to, and this is going to equal 1/7 times, in this case we found that times 3 gives us 21. So it's going to be 3/3 plus, and here we found that 3 times 7 equals 21, so it's going to be 7/7 over here. And this is going to equal to 3/21, right? Because 1 times 3 is 3, 7 times 3 is 21, plus 1 times 7, which is 7, over 3 times 7, which is 21, which gives us 10/21. So 1/7 plus 1/3 is 10/21. And let's do another one. Okay, let's do another one. So let's imagine, so let's say 2/5 plus 4/9, right? 2/5 plus 4/9. Okay, so let's do it. We're gonna try to find our least common denominator, or least common multiple. So it's gonna be, we're gonna have our table for 5 and our table for 9. 2 times 5 is 10. 2 times 9 is 18. 3 times 5 is 15. 3 times 9 is 27, right? Let's continue. 4 times 5 is 20. 4 times 9 is 36. 5 times 5 is 25. 5 times 9 is 45. And we're going to continue going out like this. So 6 times 5 is 30. 6 times 9 is 54. 7 times 5 is 35. 7 times 9 is 63. 8 times 5 is 40. 8 times 9 is 72. 9 times 9 is 81. Right, 81. 9 times 5 is 45. Now if you look at these, aha, we got it. 45. That's going to be our common multiple, our common denominator. We have to multiply 9 times 5 to get 45, and 5 times 9 to get 45. So here, we're going to equal that to 2/5 times, in this case, we're going to multiply by 9/9, because we want the denominator to be 45, and plus 4/9 times 5/5, again, because we want the denominator to be 45. And now, 2 times 9 is 18 over 45, plus 5 times 4, which is 20 over 45. And that gives us 20 plus 18 is 38 over 45. And that's our answer. And that's our answer. It's just that simple. I mean, and now, what we're going to talk about is how to subtract fractions. Well, what we're gonna find out is that subtracting fractions is very easy. It's going to be exactly the same as what we're expecting it to be. And so let's say we're going to subtract 2/3 minus 1/2. Well, first of all, what I'm going to say is that subtracting fractions is the same thing as adding fractions, except it's kind of like the opposite. So we're going to make our least common denominator table first. So 1 here, it'll be 3, and 2. 2 will be 3 times 2 is 6, 2 times 2 is 4, then it'll be 3, right? 3 times 3 is 9, 3 times 2 is 6, we got it. Our common denominator is going to be 6. This is going to equal 2/3 times, what'll give us 6 on the bottom? 2/2, because 2 times 3 is 6. Minus 1/2 times 3/3, because 3 times 2 again is 6. So we're going to have 2 times 2 is 4 over 3 times 2 is 6 minus 1 times 3 is 3 over 6, like this. And if you notice, now what we're going to do is we're going to have the same as addition. They have the common number, we can put them over it, and it's going to be 4 minus 3, which is equal, finally, to 1/6. So there you have it, and that's how you would subtract fractions. Okay. It's just addition, but in reverse. In other words, once you know how to multiply fractions, divide fractions, and add fractions, you can do subtracting fractions very easily. I'll give you another example just so that you guys can see that I'm using exactly the same technique. 4/5 minus 2/3, okay, for example. First, we have to find out what the common denominator is going to be. We're going to make our table here. 3, 5. So 3 times 2 is 6, 5 times 2 is 10, 3 times 3 is 9, 5 times 3 is 15, 3 times 4 is 12, 5 times 4 is 20, 3 times 5 is 15, and we got it. The least common multiple. Notice what that is. And what we're doing here, 4/5 times, we want the denominator to be 15, so 5 times 3 gives us 15, so we know that this has to be 3/3, minus 2/3, now we want the product to be, the denominator to be 15, so we know that this has to be 5, so it's 5/5. Now that equals, when we carry out this multiplication, we get 4 times 3 is 12 over 15, minus 2 times 5 is 10 over 15, which is equal to 12 minus 10, which is 2 over 15. And it's just that simple. So 4/5 minus 2/3 equals 2 over 15. Yes. And you can play with some examples of your own at home, so that you can get more of a feel for the technique. How do you find the least common denominator using the tables that we've been using? And now we're building up to where we're now going to talk about mixed numbers and improper fractions. Basically, a mixed number is a creature that looks like this: 3 1/5. What in the world is this? 3 1/5. Like this. Now, a mixed number like this means 3 plus 1/5. Okay, that's all it means. And so we can find out what this is in fraction form by adding them as fractions. We already know that 3 is the same as 3 over 1, and we're going to add 1/5 to it. We know that 5 times 1 gives you 5, so we're going to multiply this by 5 over 5, so that we can add them. It's going to be 15 over 5 plus 1 over 5. If you don't believe me, you can do the table just like we have been doing, and you will see that this will be the least common denominator, the least common multiple. And here we just add them. 15 plus 1 is 16 over 5, like this. And so now we know that 3 1/5 is equal to the improper fraction 16/5. Improper because 16, the numerator, is larger than the denominator 5. That's an improper fraction. But now that we've converted it into an improper fraction, we can, if we have two mixed numbers, like let's say 4 1/2, which I'm sure you can calculate is equal to 9/2, okay? Now, if I want to multiply 3 1/5 times 4 1/2, it's very easy. I just get their improper fraction form, which is 16/5 times 9/2. And I get that 16 times 9 is 144. And 5 times 2 is 10. And so, and then, this, you can leave it like that, or you can simplify it. Let me just make sure that 16 times 9. Right on the button. 5 times 2 is 10. Yeah. So this is like this. Or if you know about this, oh no, I'm not going to assume that you know about this. But you could, when you divide by 10, you move the decimal place one, so it would be 14.4. You could use a calculator for that, but or yeah, so yeah. But we'll just leave that up for now. We'll just leave it like this in fraction form. 144 over 10. Okay. The way you could, well, okay, so let me make that. So as we know, 144 from earlier, we know that 144 over 10 means, it's because I'm so uncomfortable leaving it in that form, means 144 divided by 10. And if you divide 10 into 144, you get 1, and that gives you 10. You get 44, right? So 4, you get 40, and you get remainder 4, right? So you get 4 tenths. So it's 14 and 4 tenths. So let's leave it like that. That's much nicer. And so that's the product. If we divided it, we would just multiply by the reciprocal. If we add it, we're just going to use the same technique. Let's add these two together. So let me put this up here. 3 1/5 equals 16/5, right? So let's say we want to add them. Let's say we're given the problem 3 1/5 plus 4 1/2. This is equal to 16/5 plus 9/2. Well, now we want to find out what's a good common multiple, a good denominator for these. So what we do is we have, we make our table. Okay. So we're going to have 2 times 2 is 4, 2 times 5 is 10, 3 times 2 is 6, 3 times 5 is 15, 4 times 2 is 8, 4 times 5 is 20, 5 times 2 is 10. Aha, we got it here. 10 and 10. Okay, so that's our common denominator. Notice what I'm doing. I'm listing the factors of this. This is 2 times 2 times 3 times 4 times 5 times 6. However many it takes for me to get the least one that's equal with the second one. 5, 10, 15, 20, 25, 30, 35, 40, you know. You just have to know, like. So watch. We want the denominator to be 10. 15 over 5. The denominator equals 10. Then we need 5 times 2. So that means that this is going to be 5 times 2 over 15 over 5 times 2 over 2 plus 9 over 2 times, in this case we want the denominator to be 10. 2 times 5 is 10. So we have to have 5 over 5 here. Okay? And this is perfect. So now we're in a position to add these. 15 times 2 is 30 over 10 plus 9 times 5 is 45 over 10. So it's 45 over 10, which equals 30 plus 45 is 75 over 10. So we know that this, of course, is going to be 7 and 5 tenths. You can do it the same way we did it over here. We can divide 10 into 75. So 10 goes into 75 7 times, and that gives us 70 with 5 remainder. So that equals 7 and 5 tenths. Okay, perfect. Beautiful. And we can subtract them using the same technique. All we do, when we would do it again, 16 over 5. Let's say we were subtracting this. We're subtracting this, so 16 over 5 minus 9 halves. We already know our denominator, our common denominator is going to be 10. So it's going to be 16 over 5 times 2 over 2 minus 9 over 2 times 5 over 5, because we want the denominators to be 10, which is going to be, wait, is that 16? 16 over 2, 32. Did I do that wrong? I did do it wrong. Oh my god. Yes. The previous one should have been, so let's go back to the adding problem because I did it wrong. The denominators still have to be 10, but it's 16 over 5 times 2 over 2. And this is going to be plus. We're back to the adding problem because I want to get you guys the right answer there. Because I made a boo-boo. And I want you guys to know from that mistake that now we're all human, we all make errors, and we just have to try and correct ourselves whenever possible. No one's perfect, but anyway. So 16 times 2 is actually 32 over 10, 5 over 2, plus 45 over 10. And that's 77 over 10, which is equal to 7 and 7 tenths. Excellent. Now the addition problem is correct. And then the subtraction problem, we just change this to subtraction. This will still be the same. It'll still be subtraction here. This is where it'll be different. It'll be subtraction here. And then here it'll be 32 minus 45, which is going to be a negative equals. On top, it's going to be 32 minus 45 over 10, which is going to be negative 13. Yes, negative 13 over 10, which is negative 13 over 10, which is equal to negative 1 and 3 tenths. Like that. Beautiful. And there you have it. I mean, that's how you multiply. I mean, that's how you add mixed numbers. You change them into improper fractions and you treat them like fractions. All the way down. So once you know how to handle fractions, I mean, it's very straightforward. It's the same. It's just a few basic techniques, and So let's get started. Let's get that. Let's do this again. What were we going to do? Let me see. We've covered mixed numbers, add, subtract, multiply. Let me do another example with mixed numbers, so that you guys can feel a little more comfortable. 2 1/3 plus 4 1/5. Let's just say we want to add them. First, we're going to convert them into their imperfection. So let me actually put this way up here, so I can have the whole board, so we can like follow one column from beginning to end. All right. So what we're going to do, we're going to first turn this one into an improper fraction. So 2 1/3, which means 2 plus 1/3, which means 2 over 1 plus 1/3, which we want the denominator to be 3. So 3 times 1 is 3. So it's going to be like that, right? Because 3 times 1 is 3. So, and 3 over 3 is 1. So 3 over 3 times 2 will still be 2, but it'll look differently. It'll be 6 over 3 plus 1/3, which equals 7/3. We're going to do the same thing with this. Actually, I'll let you do it at home, so you guys can get the benefit equals You want to do the calculation at home, and it'll give you 21 over 5. Right? And so now we can add these two. We have 2 1/3 plus 4 1/5 equals, oh no! Equals 7/3 plus 21/5. Wow, that looks perfect, yeah. Equals, now I'm going to let you guys calculate this at home, but the common multiple that we're looking for is 15 here. Is 15. So 3 times 5 is 15. So this first fraction is going to be multiplied by 5 over 5. And then this second fraction, 21 over 5, is going to be multiplied. We want the common fraction. We want the common denominator to be 15. So 5 times 3 is 15. So that's going to determine 3 over 3 as the fraction over there. And then here, 7 times 5 is 35. And it's going to be 15 on the bottom. Plus 21 times 3 is 63 over 5 times 3 is 15. So now we know that these two add up to 98. 65 plus 63 plus 35 over 15. And that's our answer. And then of course, if you want, you can like get it into a mixed number by dividing 15 into 98. And you know that 15 times 2 is 30 times 15 times 2 is 30. So 2, 4, 6, 15 times 6 is 90. Right? It's 90. Leaving us 8. So it's 6 and 8 over 15. And that's our answer. Like that. Beautiful. I hope you guys have followed that one. And if we had been subtracting it, it would be the same. This would become subtraction. This would become subtraction. This would become subtraction over here. This would become subtraction here. And this would be the, and this would be 35 minus 63 over 15, which if you use your calculator, you're going to get negative 28 over 15. And this is going to be equal to negative 1 13 over 15. And so there you have it, adding mixed numbers. Adding and subtracting mixed numbers, yes. What else do I want here? Let's see, we covered addition of fractions, multiplication of fractions, division of fractions, equivalent fractions. Let me see, what else should I do? I guess that's it. Well, I hope you've enjoyed this installment of how to calculate with fractions, and please let me know if it helps you. Thank you. So right now what I'm going to show you is more or less how to simplify a fraction. So I'm going to give you a technique that I learned and that is basically like one of the simplest ways to learn. So for instance, let's say I want to simplify 32 over 108. So what I'm going to do is I'm going to make a factor tree of 32. So 32 is equal to 2 times 16. 16 is equal to 2 times 8. 8 is equal to 2 times 4, and 4 is equal to 2 times 2. Which means that 32 is equal to 2 times 2 times 2 times 2 times 2. Okay? And you can confirm that 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And 108 is equal to, we're going to make another factor tree over here. Oh, oops. So 108 is equal to 2 times 54. 54 is equal to 2 times 27. And 27 is equal to 3 times 9, which is equal to 3 times 3. So 108 is equal to 2 times 2 times 3 times 3 times 3. And what we're going to do is we're going to rewrite this fraction like this. We're going to write the 2 index in this form, which is 2 times 2 times 2 times 2 times 2 over 2 times 2 times 3 times 3 times 3. And watch what happens. Whenever I have a 2 on the top and a 2 on the bottom, that equals 1. So I'm going to disappear, and these 2 as well. So these are we're going to cancel these. So-called canceling them. What we're really doing is they're 1, so they don't contribute to the actual value of the fraction. But what we're left is 2 times 2 is 4, times 2 is 8, 8 on top, and 3 times 3 times 3, which 3 times 3 is 9, times 3 is 27, 27 on the bottom. This fraction cannot be reduced further. So this is the technique that I like to use to simplify fractions. And let's do that again. I'm just going to give you a couple of examples so you guys can get an idea. And I want you guys to practice this idea at home later. So let's say 28 over what? 104, let's say. Let's just say it like that. 28 is equal to 2 times 14, which is equal to 2 times 7, right? So that means that 28 is going to equal 2 times 2 times 7. And 104 is going to equal, so we can already start writing it over here. This is going to equal 2 times 2 times 7. And 104 is 2 times 52, which is 2 times 26, which is 2 times 13. So it's 2 times 2 times 2 times 13. So we write that over here. 2 times 2 times 2 times 13. These two are going to cancel, and we're going to be left with 7 over 26. And there you have it. That's how you can that's how I recommend that you simplify fractions. And try it at home with a few more examples that you can cook up for yourself. And you'll see that this technique is very effective. You get straight to the answer.